Input-output tables. Input means to put something into the problem. Output means to get a solution out of the problem. Today we're going to review how to set up or create an input-output table for a given linear function. The first scenario I have is a real-life application. It states, Storm makes $3 on each pair of sunglasses he sells. Create an input-output table showing the relation. So if you look, I've created basically a T-table with two columns, our input and our output. Now what we need to do is we need to start by writing an equation. Okay, I'm going to let x equal the number of pairs of glasses that Storm sells. Number of pairs. I'm going to let y be Storm's profit. So my equation would be the amount he makes is equal to 3 times the number of pairs he sells. So 3 times x is just 3x. So I have two columns on my table. The first column is my x value. Now when you're deciding on x values, you need to look at your equation. My equation is y equals 3x, and sometimes we just put y up here, but I'm going to write y equals 3x. This is my output. When you pick your values, you want to look at what the coefficient is in front of your x, which is 3. If it's a fraction, it makes a big difference on what number you pick. Now, when we pick values, it can be any value we want. But we have a problem here. Could Storm sell a negative amount of sunglasses? Probably not. So maybe sells 0. I'm just going to pick some other values. 1, 2, 3, and 4. It really doesn't matter which ones you pick. Well, let's think about it. If Storm sells 0 pairs of sunglasses, that'd be 3 times 0, which is just 0. He makes 0 profit. If Storm sells 1 pair of glasses, that'd be 3 times 1, which is 3. If Storm sells 2 pairs of glasses, that would be 6. 3 pairs of glasses, 9. And then 4 pairs of glasses, 3 times 4 is 12. Now what you have is you have two values. You have your input, which are your x values, and you have your output, which are your solutions, or what you got once you put it into your equation, thus giving you an input-output table. Let's try one, but let's just start with an equation. So I'm going to start with x, and my y is going to equal whatever I pick for x plus 9. Now, it doesn't matter in this problem whether x is positive or negative because it's not a real-life application. So for the sake of getting some negatives in there, I'm going to do -2, -1, 0, 1, and 2. Whenever we graph linear functions, we try to pick both positives and negatives. So in the first problem, it says I pick -2, so I'm going to substitute it in. So -2 plus 9. If I owe 2 plus I have 9, I'm at 7. -1 would be -1 plus 9, which is 8. 0 plus 9 is 9. 1 plus 9 is 10. And 2 plus 9 is 11. Looking at that there's a pattern between them. As I increase my x by 1, my y value increased by 1 as well. Let's try another one. This time I threw in a negative in front of my x. So we have to make sure to do our order of operations. I'm once again going to pick some x values. Doesn't really matter what you pick. -2, -1, 0, 1, and 2. Now in this problem it says y is equal to -2 times whatever you pick for x plus 1. Well, I'm going to kind of do my work off to the side here. So for -2, when I put in a -2 for x, I get -2 times a -2, which is a +4, plus 1, which yields 5 as an answer. Let's try -1. So -2 times -1 is 2, plus 1, because it says add 1 at the end, I get 3. 0, -2 times 0 is 0, plus 1 is 1. 1. Now I got to think backwards. Negative 2 times 1 is negative 2. Plus 1 is negative 1. And one last one. Negative 2 times 2 is negative 4 plus 1 is negative 3. And I have now created a table for those values. Okay, I'm going to do one more problem. And then we are done with input-output tables. Now the last problem I picked is 1/3 x minus 4. Now if you look, a third is like dividing by 3. So the trick to doing a t-table or an input-output table on these is to make sure that whatever you pick is divisible by 3. So when I pick my positives and my negative numbers, I'm going to want to pick things that are divisible by 3. Otherwise we're going to end up with some messy fractions. So I'm going to pick negative 6, negative 3, 3, and 6. So 1/3 is like dividing by 3. So my first problem is going to be 1/3 times negative 6. So negative 6 divided by 3 is negative 2. Minus 4 more is negative 6. Let's try another one. 1/3 divided by negative 3 is negative 1. Minus 4 is negative 5. 0. 1/3 times 0 is 0, so it's always a good one to pick. Minus 4 is negative 4. 1/3 times 3. 3 divided by 3 is 1. Minus 4 is negative 3. And one more. 1/3 times 6, or 6 divided by 3 is 2. Minus 4 is negative 2. And I've completed my input-output table for y equals 1/3 x minus 4. I hope this is helpful in creating your own input-output tables.